Alright, so page 3 of the 7.4 mixed examples to sort of make sure that you have these down before we get into the next set of notes. So, problem number 6 on these set of notes. An unfair coin, so it means it's weighted weirdly, maybe it's a wedged coin, in some way it's weighted, where it's heavier on one side versus the other. So maybe it's got different metals on one side of the coin versus the other side of the coin. Alright, so in this particular case it's unfair, so it doesn't land 50-50 every time. And so the probability distribution is given, so we're counting heads. So we get 0 heads and 3 tosses, which means all tails. 1 head, which means 2 tails. 2 heads, 1 tail, 3 heads, no tails. And then the probabilities. They give you all but the last probability. And a lot of times we do this because it requires you, before you use the probability table, it requires you to remember the important aspect about probabilities. When I have a probability distribution, I'm listing all possible outcomes. Well, remember, all possible outcomes should add up to 1. So if I know all but the last one, to find this missing probability here, what I do is I take 1 minus the sum of the rest of the probabilities. So I have to add up all of these, so I take 0.064, add it to 0.288 plus 0.432, and that comes out to 0.784. Alright, so that's the sum of all of these probabilities, and so I know the last piece is what's left over, so I need to take 1 minus that, and that's the missing piece of the puzzle. And so when I take 1 minus that, it comes out 0.216. So the probability, so this missing probability of getting 3 heads is 0.216. So that's the missing probability here. And I need that to answer my question. So you have to remember, probability distributions, the probability should always add up to 1. So if they're missing a piece of the table, you use that fact. Right, then we're going to use it. What's the probability of getting at least 2 heads? Well, the probability of getting at least 2 heads is getting the 2 heads, or the 3 heads case, which is why I needed this, because it's the probability of getting 2 heads plus the probability of getting all 3, which is the one I just found. And again, it's a straight addition because probability distributions by definition are set up as mutually exclusive, and it should make sense. If I have 2 heads, I can't also have 3 heads, right? I'm either 2 heads and 1 tail, or I'm 3 heads and no tails. And so they are mutually exclusive events. I can't be both of those things at the same time. So it's just a straight product between the two. So I add up the 2 probabilities. And so the chance of getting at least 2 heads with this unfair coin is about a 64.8% chance. 0.648. Alright, the next example, which is basically this example takes up the whole rest of this page, is again a sequence of letters. And so I picked the word computer, but I did change it a little bit. I dropped the S, if you'll notice. There is only 8 letters total, and I'm going to pick 3. No more than once each, so no repeats, sequence of 3, so we're going to pick 3, and this is a permutations. Alright, no repeats, no more than once each. Sequence means order matters, and so it's a permutation. And you can use the permutations formula if you want to, but since it's only picking 3, I think it's easier to do the subtraction. Remember, permutations, either you plug it into the formula into the calculator, which does the subtraction multiplication for you, or you just go ahead and do it yourself. And I'm just going to do it yourself because I think it's easier to go ahead and write it all out. So, and I'm not going to actually use the formula from the calculator. I'm going to just write it out and subtract every time I pick a letter. But again, you can solve it however you want. Just check your answers versus mine. What's the probability my sequence will contain an R? So probability that we pick an R. What's the number of ways where I pick R over the number in my universal? And so remember, when I'm selecting R, and since we've done a few of these, I'm going to go through this fairly quick, so I'm just going to write out the multiplication and talk about it up top. Alright, so I pick R. Well, there's only one R in my word computer. But then I'm not done. It's got to go into my sequence, right? So the R could show up in the first spot in the sequence, the second spot, or the third spot. So I pick R, and I have to place him in one of the 3 positions in my sequence. So the next number is 3. That 3 represents my R being placed in one of the 3 spots in my sequence. And then I'm not done. I still have to finish out my sequence, and there's 2 spots left in my sequence with letters that are not R, right? How many letters are not R? Well, there are 7, right? If I take away R, there's 7 letters. So for the first spot, there were 7 letters to choose from. And then the second spot, there's only 6. So there is my outcome, where I select the R, place the R in my sequence, and finish out my sequence with letters that are not R, making sure once I pick a letter, I can't pick it again. Then the universal set would mean I pick any 3 to form my sequence. Well, any 3 would mean I had 8 choices for my first pick, 7 choices for my second pick, and 6 choices for my third pick. So my universal set is the product 8, 7, 6, or you could use permutation. It'd be permutation. I'm selecting 3 letters out of 8. You could find it that way too. It does this multiplication for you. Again, it's up to you how you want to do it. All right, so up top, the event multiplies out to 126 is the number of outcomes with the letter R out of my universal set 336. So there are 336 total sequences of 3. Out of those 336, 126 of them contain the letter R, and then I find the decimal approximation, which is actually exactly 3.375. Alright, next example. What's the probability they do not contain the letter R? Which actually the complement to the previous event. You'll see that it is. Now, suppose we didn't have the previous event, so I'm going to suppose part B is a separate question. We didn't have part A, but it should come out 625. So we'll check to see if it does. Alright, so probability that we do not pick R. Alright, so it's the number of ways to not pick R over the number in my universal. And so my universal is the same. Right? I'm picking 3 letters in my sequence. It would still be 8 for the first choice, 7 for the second, 6 for the third. Up top, I'm picking 3 letters and all of them are not R. So I am throwing R out of the problem, which means I have 7 letters to start with. So I've got 7 letters that are not R for the first spot, 6 for the second spot, and 5 for the last spot. So up top, it's a product of 7, 6, 5. In the denominator, it's the same product we had before. So this is 336 total outcomes. When I take 7, 6, and 5, 210 of them do not contain the R. And if you look, that is the complement to this event. If I take 206 away from 336, I'm left with 210, and so it is the complement to the previous event. So if I had taken 1 minus 0.375, it would give me the same answer, which is 0.625. But again, I'm going on the assumption we didn't have the previous example. Alright, but just so that you're aware, those 2 events are complementary events, right? So we're still picking the R, so what's the probability the sequence will contain the R? But we're adding a part to this. We're not only picking R, but we want to pick a spot on an N. On an N means, remember, my sequence of 3. So that means he can go on either one of my ends, he just can't go on the middle. So it changes the problem a little bit. Alright, so probability that we not only pick R, but we put them on an N. Well, it's the number of ways to do that, the number in my events over the number in my universal. I'm not going to write out the universal set. We know it's 876, which is 336. So 336 for my universal. But it changes the first, basically it changes this first one by 1 number. Alright, so what's going to change is this 3. I'm picking R. Well, there's only 1 R to pick. But this time, there are only 2 places R could show up in. So that second number is 2. Right, I pick R, and I can put them in 2 spots. Right, so 1 times 2 is the way I can pick R, and then I finish off my sequence with my letters that are not R. So there are 7 for the first letter that's not R, and 6 for the second. So it changes that first problem by, instead of having 3 places R could go, I've narrowed it down to 2 places R can go. So now it's 2, 7, 6. Which it makes the group smaller. Now there's only 84 outcomes out of my total 336. So I went from having 126 to 84 because we threw out all of the outcomes where R was in the middle. Right? and that left me with 84, and then we find the decimal approximation to that, right, which actually comes out to a really nice 1/4, 0.25. Alright, next outcome. Find the probability you get the sequence COM in that order. So C in the first spot, O in the second spot, M in the last spot. So probability you get COM is your letter combination in your sequence. Alright, so number of ways to get COM over the number in my universal. Well, my universal was still 336. Again, that won't change until we get 7576. Well, that's a specific sequence. There's only one sequence with COM in that order, right? C in the first spot, O in the second, and M in the third. And so that's one of my 336 outcomes. All right, so 1 out of 336. Right, so the last one for this particular problem, I don't know why that's F instead of E. What's the probability the sequence contains the letters C, O, and M, and it didn't say in any order, so that means I can have any order, right, not just the one above. That's the difference between this one and the previous problem. I just want the letters C, O, and M. It didn't tell me what order they're in. They can be in any order, so C could be first, second, or third, O could be first, second, or third, and M could be first, second, or third. Alright, so I want to find the probability. We're going to pick C, O, and M in any order. Well, it's the number of ways in my events over the number in my universal. Well, the event is, my universal is still 336. My event is I'm only selecting, so I'm going to pick 3 letters in my sequence. Only those 3. So when I'm setting up my events, I have to fill out my 3 spots with those specific 3 letters. And so for the first spot, I could pick C, O, or M. So there's 3 choices for the first spot. But now I've picked one of them. Right? So I picked O for the first spot, which means I only have C and M for the second spot. Once I've picked 2 of the letters, there's only 1 left over for the third spot. And so my event is 3 times 2 times 1, so there were 6 outcomes out of 336 that contain C, O, and M. Or if I write the decimal approximation, 0.1786. And it's important that you understand the difference between this problem and the previous one. The previous one was one of these 6, right? I had one order where I had to put, because it was in order. This allows me just to pick those 3 letters, but I could order them anyway. So I could C-O-M, I could have C-M-O, I could have M-C-O, M-O-C, and C-M-O, and C-O-M, and there would be the 6 outcomes. So those are the 6 out. One of them was the one in the previous group. So again, it is important that you understand the difference between how those 2 questions were worded, because it makes a big difference. I went from 1 out of 336 to 6 out of 336, and that was a difference of 5, and that's significant. Alright, well that finishes up this particular page of notes in the 7-4. I believe we have one more page to go, and then we're done with the basics once we get through that last page in the 7.4 notes. Alright, so we'll stop there.